Today, I would like to investigate this typical calculus 1. Today, I would like to investigate this typical calculus 1 question with you guys. We have x plus 2y is equal to 4, and we are going to find the maximum of square root of x plus square root of y. And to get a sense of what's going on, let me set up a table of x and y values, and also square root of x plus square root of y. First, notice this x is in this square root. Likewise, this y is in this square root. So that means x and y cannot be negative. Otherwise, we get to the complex world, which is no good. But we can have 0 for x. In that case, y has to be 2. Then we get square root of 0 plus square root of 2, which is square root of 2. And we can also have y equals 0. In that case, x has to be 4. And we get square root of 4 plus square root of 0. And that's just going to be a regular 2. And this 2 is bigger than square root of 2. So does that mean we are done? No, because what happened to fractions? What if I pick x equals 1? Then in that case, 1 plus 2y is equal to 4. 2y is equal to 3, so y is equal to 3 over 2. And we get square root of 1 plus square root of 3 over 2. 3 over 2 is bigger than 1, which is going to be bigger than square root of 1, which is 1. So this is 1 plus something bigger than 1. So this result has to be bigger than 2. So once we get to the fractions, there's no way for us to plug in all the fractions into this and then test it out, right? So we must have a better way to do it. So this is our goal. We want the x and y so that the result here is the biggest possible. So here's the deal. This is the result that we want to get the maximum out of it. First, let me just call that to be s for the sum of the square roots. And then right here, what we can do is just solve a variable. Let's say solve for x. By moving this to the other side, we get x equals 4 minus 2y. And then you see we can put this into this x, and then we can say s is equal to square root of 4 minus 2y plus square root of y. And now we see this function is in terms of just y now, so we can do the typical calculus 1 stuff. And that is find the first derivative and then find the critical numbers, and then we test them out to see which one is going to give us the maximum. And let's just find the derivative, s prime. And by the way, this is just a function in terms of y, so sometimes we can write it as s of y. It's just a notation for this. So this right here is s prime of y. Find the derivative of square root. We get 1 over 2 square roots of the inside. And then don't forget the chain rule. The derivative of 4 is 0. The derivative of negative 2y is negative 2. And then the derivative of square root of y is 1 over 2 square root of y. And now we can combine this and that together. So the common denominator will just be this times that. So we will have 2 square root of y times square root of 4 minus 2y. And then for this fraction, we will need to multiply top and bottom by this. Here we have a negative. It's 1 times that. So just 2 square root of y. Plus 1, we have to multiply top and bottom by that. So 1 times this is just square root of 4 minus 2y. Now, if you look at the structure of this, we can find the critical numbers. And remember the criteria for a number to be a critical number. It's where we make the derivative equal to 0 or making the derivative undefined. But the number also has to be in the function of this, in the domain of the function here. So the first thing is that we will have to set the top to be 0. So this is negative 2 square root of y plus square root of 4 minus 2y to be 0. And then we should also look at the bottom and make this factor equal to 0 So let me just put that down real quick. This right here, it's pretty easy to see that y is equal to 0. And we consider this as a critical number because 0 will make the derivative undefined because we get 0 on the bottom. And 0 is also in the domain of this function. Y can be equal to 0. So this is technically also a critical number. And then lastly, we also make this because it's a product of two things. So we also consider square root of 4 minus 2y is equal to 0. And then right here, you can see that y has to be equal to 2. For this one, though, we just have to solve it real quick. Move this to the other side maybe. So square root of 4 minus 2y equals positive 2 square root of y. Square both sides, cancel this and that. 4 minus 2y equals 2 squared is 4. Square root of y squared is just y. So move this to the other side, we get 6y equals 4. Divide both sides by 6 and then reduce by 2. Y is equal to 2 over 3. Okay, so we have 3 critical numbers. And now what? Here is the deal. We technically should come here and then look at the derivative and then test it out to see if it's positive, negative, and so on, so on, so on. So let's just do that real quick. Here, we have 0 to test out, and then 2/3 to test out, and then 2 to test out. But I will tell you, at 0, it's undefined, right? So it's open circle. That goes open circle for the 2. This is for the derivative. And then at this right here, it will give us 0. We cannot have y less than 0. Okay, likewise, we cannot have y bigger than 2. If y is bigger than 2, this right here is going to be negative inside. And if you pick a number between 0 and 2 over 3, that's the 1/3. If you plug in here, I will just tell you, we'll get a positive result. If you put a number that's in between of this and that, let's say 1, put it here, you'll get a negative result. So you will see the first derivative changes the sign from positive to negative at 2 over 3. So we will have a maximum at y equals 2 over 3. So now we can come back here and I can tell you we should have y equals 2 over 3. And if y is equal to 2 over 3, let's just solve for x real quick. So that is x plus 4 over 3. It's equal to 4, and then 4 is the same as, now let's just say 4 is the same as 12 over 3. So minus the 4 on both sides, we get 8 over 3. So x is 8 over 3. And that's how we find it. Right? X is that, y is that. And the maximum value will just be square root of 8 over 3 plus square root of 2 over 3. And of course, this right here, let's just simplify it. Square root of 8 is the same as 2 square root of 2. And then we still have the square root of 3 on the bottom. And then combine both of the things on the top. That will be 3 square root of 2 over square root of 3. And in fact, we can simplify this. This becomes 1, and this becomes square root of 3. Square root of 3 times square root of 2, final result, square root of 6. That's pretty much it. And in fact, there are other ways to do it. For example, if you just want to use algebra, you can use something called the Cauchy inequality. I will make another video for that. And the other way is called the Lagrange multiplier, and that's something that you will learn in Calculus 3. You don't have to do that in here because we only have 2 variables. We could simplify this into just one variable function. But imagine if we have 3 variables here, x, y, z, and then square root of x plus square root of y plus square root of z. Then in that case, we will have to use Lagrange multiply. I will make another video in that regard as well. But for now, that's it.